Hello, in this video, we're going to work on question number 1 in this computer skill lecture, and I will focus on to understanding the central limit theory. Okay, and also we're going to learn how to use Excel to do the calculation. The diameter of the bushings turn out by a manufacturing process is a normally distributed random variable with a mean of 4.035 millimeter and the standard deviation of 0.005 millimeter. A sample of 25 bushings is taken once an hour. And within what interval should 95% of the bushing diameter fall? Second, within what interval should 95% of the sample means fall? Last one, what conclusion would you reach if you saw a sample mean of 4.020 and a sample mean of 4.055? Okay, so as you reading these questions, the question number A and B might cause you the confusion because both of them are asked for the intervals. Sounds like they all asking for the bushing diameters interval. But what are the differences? So what are the differences? So in order, before you work on the problem, you need to know the difference. Otherwise, you're gonna get in the wrong answer, right? So A, the interval, the 95% interval of the bushing diameters. So for the A, it's literally asking for that one bushing diameter. So basically, you go to the sample, you random pick one, right? You go back one to pick multiple times, and to see, hey, what is the 95% interval? It's almost like a just sample size equal to 1 scenario. Okay. B, within what interval should the 95% of the samples mean falls? So B is the one looking for the sampling distributions. Okay, sample distribution. Basically, we are looking at the mean, the sample means 95% range. Okay, 95% range. So that is the difference. A is focusing on, hey, let's just pick one bushing. And then what is the 95% intervals? So the second one is, hey, we go back 1,000 times. Each time we're collecting 25 bushing and then calculates mean. For that mean, what is the 95% range? So therefore, A and B, the formula you're going to use will be slightly different. Okay, so let's do it together using Excel. Okay, when we are using Excel, as I already mentioned, A are focusing on that one bushing. Random pick one, what is the 95% range? The B is related to the sample distribution. So therefore, in the lecture, we look at this formula. So the mu plus minus z times sigma square divided by square root of n. So that one will only apply to my question number B. So for question number A, it's literally just focusing on that one individual person, or one individual bushing. So you don't really need this formula. Or you can just thinking about the scenario as, hey, we still consider a sample mean, but the sample size equal to 1. So you can think about like that way as well. So if that's the case, the formula you're using is mu plus minus z times sigma. That will be able to answer the question A. For B, since the sample size we already know is 25, the sample mean has to base on that sample size to determine that sample means 95% range. So therefore, you have to make sure you use square root of 25, right? So that's the main difference. Okay, first, teach you some good habit. So it's a good idea that every time you do the Excel, as you reading the question, you write down your parameters value on your Excel so that it can prevent the typo later on. You're going to use those numbers again to do the calculation. So based on the question, I know the population mean, the diameter is 4.035. And the population standard deviation is 0.005. And the sample size that we will use in question number B is 25. Now, what we don't know is our Z statistic, right? So the Z statistic based on the question here, let me go back, is 95%. So 95% range based on what we learned so far. If it's 95% interval, we're going to use the value 1.960, right? So we're going to come back here, type in 1.960 because it's 95%. That Z value is 1.96. So now we are able to calculating my lower bound for A. So the lower bound is when we are using the minus sign. So equal to the mu minus sigma. Okay, we don't need to divide by square root of n because the question number A, we are not looking for the sample mean. We literally just look at that individual one part. So we don't need to divide by square root of n. And then times z. Okay, so that's going to give me my lower bound. Push enter, and you'll get 4.0252. And for my upper bound, so we are using the mu plus instead of using minus. Using plus give you the upper bound of the range and times the z statistic and times the sigma. So you can see sigma times z or z times sigma, you get the same one, right? And then push up, enter. So that gives you the upper bound. So basically, the 95% range for that one part will be falling between 4.0252 to 4.0448. Okay, B is the one we're going to focus on. Hey, let's see the sample size equal to 25. For that sample mean, what is the 95% range? So if that's the case, we're going to use the sample size N25 in my calculation. So my lower bound equal to mu minus z times sigma divided by, so the square root of n on the Excel formula is QRT. We learned that before when we learned this as QRT before. It stands for square root, parentheses, my sample size, I will select it. So you notice that I never type any number when I do this calculation. Okay, that's the one thing I, again, recommend you to do is always list your parameter value on your Excel as you reading the questions. So that will really prevent you to creating typo later on when you do the calculation. So once you lay out all your parameters value, later you do any formula calculation, you can just select the value. So that will really help you to prevent unnecessary calculation error. Okay, so this give me my lower boundary. My upper boundary will equal to mu. We're going to choose plus sign. Z statistics times sigma divided by SQRT parentheses 25. That will give me my lower upper boundary. So my upper boundary is 4.03696. As you can see, this range is much narrower than the slightly narrower than the individual parts, right? So A and B. So now we look at question number C. What conclusion would you reach if you saw a sample mean of 4.020 or a sample mean of 4.055? So basically, you pick out one of the specific sample, had 25 bush, and you calculate sample mean, you got 4.020. You go to another sample, calculate the mean, you got 4.055. So if you look at this two number, compare with the answer from B. So the B give you the 95% range for your sample mean is 4.033 to 4.036. So for the first number, 4.020, that is smaller than the lower bound, right? And for my second number here, 4.055, that is larger than the upper bound. So that means for that two sample, they are not falling to this 95% range on my sample mean. Okay, so that's going to be the conclusion. So for those two samples, you pick it out specifically. For their mean, they are not falling to this 95% range of my sample mean. Okay, that's the conclusion. Okay, so again, for the computer skill lectures, if you think I walk through a little bit too fast, make sure as you walk through, watch this video, pause the video as I type in using those formula to make sure you select the right value. And after you type the formula, make sure you match in the number as well to make sure you actually use the right formula in your Excel. Okay, feel free to reach out to me if you have any question. Good luck for your learning. Bye.